So today we're going to be talking about logarithms. Logarithms are basically the opposite of exponents. Like multiplication and division are opposites. Basically, you've got logarithms and exponentials are opposites. So what we're going to do here is logarithms. What I want to do is I want to think about, let's say, I don't know. Let's say you are let's say that you are, and I am 6 feet tall. Okay. And let's say that my height doubles every year. Which would be messed up, but so it's 2021, right? And I would be 6 feet tall. That makes sense? Now, in the year 2022, how tall would I be? I would be 12 feet. In the year 2023, I'd be how tall? No, I'd be 24 feet. Okay. I'd be super, super tall. All right, so let's think about this right now. Basically, in the year 2022, I've doubled. In other words, I am 2 times as big as I was when I started. In the year 2023, 2 years later, I am 4 times as big as when I started. If I was to keep going, in 2024, I'd be 48 feet tall, which that'd be really, really tall. So let's check this out. In year 1, I multiplied by 2, right? In other words, I did 2 to the first power, right? In year 2, I'm multiplying by 4 from the original, right? Because 6 times 4 is 24. So that'd be 2 squared. Is everybody following me so far? So in the third year, I'd have 2 cubed. So what kind of function is going on here? This is basically just a what? Exponential. Did everybody see how it's an exponential, right? Because I'm just multiplying 2 every time. So let's think about this. At 2021, how much have I grown? 0. I haven't grown at all, correct? So if I think about it, 2 to the 0 is what? 1. Let's think about what this means. What this means is at a rate, so your base number is your rate. Does that make sense? You can think about your exponent as time. And you can think about this answer as your result. So basically what I'm saying is at a rate of 2 of doubling each year, after 0 years, I will be the exact same size. My result will be the exact same size as when I started. Does that make sense? So let's rethink about how we did this first year. So at a rate of doubling each year, after 1 year, my result is twice as big as when I started. Everybody following where I'm going with this? So how could we rewrite 2 cubed or rethink about this one? What's the rate here? I'm doubling each year. What's the time? 3 years. What is the result? 8 times as big as when I started. Everybody following me so far? Yes, I do want you to write rate, time, result. Rate, time, result. These are the 3 key factors to an exponential, right? Okay, here's a question. How tall was I in 2020? 3 feet. Why? Yeah, if I'm doubling each year, then the year previous I'd have to be half of what I am now. So let's think about it. How could I represent this half in exponential form? What 2 to the negative 1 is 1/2. Ah, that's why 2 to the negative 1 is 1/2. Why? Well, it's because at a rate of doubling each year, if I go 1 year in the past, reversed, right? Then I'm actually 1/2 the size I am now. Everybody see that? And so what about the year 2019? Well, I've been 1.5 feet, 1.5 feet. And once again, we could say this at a rate of 2 years in the past, I'd be 1/4 of the size I am now. Does everybody see where we're going with this in terms of rate, time, and result? So here's what I want you guys to write down. 2 cubed equals 8. We got 2 to the third is equal to 8. In terms of rate, result, and time, what does this mean? Well, logarithms say, I don't like the way this is set up. Logarithms say this. Log base 2 of 8 equals 3. How has those numbers changed and what does this logarithm mean? Let's think about it. So the 2 we know represents what? Rate. 8 represents the result. So 3 must represent the. So let's think about it. An exponential function says, hey, I'm doubling every year. How tall will I be after 3 years? A logarithm says, I'm doubling every year, but I'm going to go ahead and tell you what the result is. I'm going to be 8. I'm going to be 8 times as big as when I started. How long is it going to take for me to get there? So you can see that the difference between logarithms and exponentials is the question being asked. One's asking, what is my result? The other is asking, how much time? Does that make sense? So in one case, in the exponential case, we're asking, what is the result after a certain period of time? And in the logarithmic case, we're asking how much time has passed after, after doubling at a certain rate. So let's do a problem real quick. Log base 2 of 16 equals what? So let's think about what this means. It's saying if I double every year, how long is it going to take me to get to 16? You could literally check by putting in your calculator going 2 times 2 times 2 times 2 and see how many times it takes to get to 16. And the answer is what, guys? 4. Log base 6 of 216 equals what? And no, I'm not going to give you any hints, but don't shout it out loud. I want you to write this down on your paper, in your notes, and think about how you would solve this one. All right, so let's start with this first one. We got log base 6 of 216. Log base 6 of 216. What is the rate here? So how many times do you multiply 6 to be times itself to get 216? 3 times. Everybody see that? So I can do, actually, like I was saying, you could take your calculator and you could just say, hey, 6 times 6. Okay, that gives me 36. So that's 2 times 6, or 6 twice. And then I can do another times 6. Oh, that gives me 216. So that's 3 of them. All right. So we got log base 8 of 64. So let's think about what this means. It's saying that if I'm multiplying by 8, or if 8 is my base each time, how many times is it going to take me to multiply 8 by itself to get 64? And what's the answer, guys? Twice, because you got 8 times 8 is 64. Everybody cool with that? All right, before I do this last one, I'm going to give you one more quick and easy one. So what about log base 3 of 9? Log base 3 of 9. So it would be 2. Why, guys? 3 squared is 9. All right. What about log base 5 of 125? 3, right? Log base 5 of 125 would be 3. 5 times 5 is 25. 25 times 5 is 125. So here's the question. What is log base 5 of 1 over 125? -3, because we're going in the past. Everybody sees that? Or you can think about it as 5 to the -3. Now, there's one more way to kind of rearrange these logarithms. And we use what we call a spiral method. So basically, if you go straight down on this, your base, and you make a spiral like this, the numbers that you hit are how the logarithm is done. I'm gonna explain what I mean. 2, 8, 3, right? 2, 8, 3. Y'all see how this is literally just the same thing, just re-represented. And guess what? It works both ways. So if I use the spiral method here, I have a log base 2 of 8 is equal to 3. Then now I can say 2 cubed must be equal to 8. Does everybody see that? So let's try it over here. So we've got log base 2 at a rate of 2, a result of 16 is equal to 4. So if I use the spiral method, basically what I'm saying is 2 to the 4 equals 16. Do y'all see that? If I redid these, I could say 6 cubed is equal to 216. Did these right here, 8 squared is equal to 64, which we know is true. I did these right here, I'd have 5 to the -3. It's 1 over 125. Everybody's cool with that? Makes sense? All right.